Hello, I hope you are doing well. Welcome to Dev School channel. Today, we're going to take a Dribble design and design the screen in a .NET MAUI application. Specifically, we're going to create the XAML code of the application as best as possible. It is an artificial intelligence image generator application that looks pretty good in the Dribble design. In this video, we will focus only on the first screen. Later, in another video, we will create the rest of the screen so that we have all the interfaces and even, at some point, maybe the implementation with some APIs such as DALL-E to generate images with artificial intelligence. The .NET MAUI application looks like this. We have a collection of the possible friends that we could have as part of the graphical interface. We have also implemented or used a NuGet package that allows me to have this nice design on the cards that looks pretty good. Finally, we have the button to create a new image. This is what the graphical interface will look like once we finish designing it or creating the XAML code. I'm going to open Visual Studio. I have already previously created a new project from scratch. It's completely code from scratch. I haven't modified anything. And we're going to create all the necessary code to be able to replicate this graphical interface. The first thing we're going to do as part of the project, which I have called DALL-E app, is to create a new folder called Views. This is because in the folder we want to keep all the screens of the application, the graphical interface screens. Within this Views folder, I'm going to create a new item, specifically a content page, for which we select the .NET MAUI category, select a content page of the XAML type, and we are going to change its name, for example, to Dashboard View. Once we have created our screen, what we're going to do is modify the background color of the application. We're going to use a color that I have previously selected, which is this one that you can see, which is 10, 12, 16. It is worth noting that as part of this application, I'm not going to use resource dictionaries, so that you can see what the different properties are that we're going to apply to each of the controls. Although it could definitely be done to keep the styles in a single file, for the moment we're going to do it this way. Once we have done this, to see the changes, I will open the app.xaml.cs file, and instead of initializing the app shell, I will indicate that I want to create a new instance of the dashboard view. The necessary namespace is automatically imported, and I will start deploying the application on my emulator to see how the application looks. Then I start running the application and give it a few seconds while the deployment of this application takes place. After waiting a few minutes or seconds, we can see that we now have the graphical interface of the application here. We have this dark background that we have applied from the XAML file. The next step we're going to take is that we have to divide the screen of the graphical interface into different sections. For this, we're going to use a grid. I have previously calculated the values of each of the sections that we can see as part of the graphical interface. For the text, for this collection, for this control, for the button, etc. Then I'm going to define a new grid as part of the graphical interface. For this, I remove the default vertical stack layout, and in its place, we're going to create a grid with a margin of 25, 25, 0, 0. Remember that in .NET MAUI, this number 25 indicates the margin to the left, the top margin, the margin to the right, and the margin downwards. Later on, I'm going to define the row definitions property, and this is where I start dividing the grid into different sections. I'm going to indicate that I want 10% for the first section, 20% for the second section, 15% for the third, 45%, and finally the value of .1 star. I really like to handle this type of nomenclature because it allows me to calculate the total height of the graphical interface as such, and thus I can delimit a percentage type for each of the sections. So each of these values represents a percentage. For example, 0.1 represents 10%, 0.2 represents 20%. What you should notice is that the total sum is equal to 1, so that you have control over each of the sizes of the sections. Next, I'm going to create the first grid that will serve me to define this upper part of the hamburger menu and the profile image. So for this, I'm going to indicate that I want a second grid with a margin of 0,0,25 to assign a margin to the right and finally a 0. And as part of this grid, I'm going to define a couple of columns that have the same space. The first step we're going to take as part of this grid is to define this hamburger icon, which can be clicked to display some additional options. In our case, we are only going to draw the hamburger menu icon. How can we do this? Well, there are different ways. We could import an image, use a font, but this time what we're going to do is to use some standard elements of .NET MAUI to avoid using so many images. So I'm going to create a vertical stack layout with its vertical options set to center the content. And inside the vertical stack layout, I'm going to nest or rather position one element after the other, each of these lines. To do this, I'm going to define a first rectangle with a fill to fill the first line equal to CACDD3. I'm also going to indicate that I want a height request equal to 2. It has to be a very small size because it is the size of these images or lines that we see here. I'm also going to indicate horizontal options equal to start and width request equal to 25 to define a width of the first line. I'm going to go to the emulator and you can already see this first line that we have as part of the graphical interface. Let's define the second rectangle. So I'm going to copy this first rectangle. I'm going to leave the same fill color. I'm only going to change the height request that will remain equal to 2. Horizontal options equal to start. The width request will be equal to 35. And I'm also going to add a margin equal to 0,5,0,0. With these values, we can already see that we have the hamburger icon in a correct way and without the need to be using so many images. Next, we're going to create the profile image part, for which I'm going to use a border control. So, after the vertical stack layout, which I'm going to compress, I'm going to indicate that I want a border. I want to position the border in column number 1. I'm also going to indicate that I want a height request equal to 75, horizontal options equal to end, to position the element at the end. I'm also going to indicate that I want a stroke shape equal to round rectangle, since I want to define a specific rounded rectangle that is circular, for which I'm going to indicate 80, 80, 80, 80, and a width request equal to 75. Inside the border, we have to specify which element we want to nest inside the border. In my case, it will be an image element with an aspect equal to aspect fill, a height request equal to 100, horizontal options equal to center. For the source, we're going to indicate that we want an image source called profilesquare.jpg that we have not yet added, and a width request equal to 100. I'm going to close the element, stop the application execution as I'm going to import the images as part of this resource folder, specifically about the images folder. Then I'm going to import the images. Okay, I have imported all the images. With this, I'm going to start the application execution again to see how this section we have added, which is the profile image of one of the people. Perfect. After a few minutes, we can see that we already have the hamburger menu icon and the profile image. The next step, according to the image we have chosen, is to create the titles for this screen of the application. To do this, I will go back to the XAML code and compress the grid that already contains the information we need. Next, I will add a vertical stack layout in row number 1 and set its vertical options equal to center. Inside the vertical stack layout, I will place a couple of label elements, which are a couple of text. I will set the label font size equal to 30. For example, and a text equal to create incredible universes, and a text color equal to white. Let's see how the change looks in the application. We already have the emulator here and we already have the application title here. I will copy the label element because I want to modify some properties. For example, I will add a margin 0, 10, 0, 0. The font size will no longer be 30, it will be 20. And a text. It will be equal to join your friends. And a text color that will be equal to ACB1BB. I save the changes and go back to the emulator. We already have this second text that looks quite good. The only problem is that the font being used as part of the graphical interface corresponds to the default typography of a .NET MAUI application. Even as part of the document, we can see which typography is being used. The problem is that this typography is a paid typography. Therefore, I had to look for a free option, which I'm going to show you next. To do this, I stop the application execution and import the fonts as part of this folder called Fonts. I import the Nexa Heavy and Nexa Extra Light fonts. To use these fonts or to give them an alias, I'm going to go to the MAUI program.cs. Here I can copy one of these lines a couple more times. I'll write the name of the font, which is Nexa Extra Light.ttf. We'll call it Nexa Light. I'll also copy the name again and change Extra Light to Heavy, and the name will be the same as Nexa Heavy. I save the changes, go back to the XAML file, and assign a font family equal to Nexa Heavy for the first label element. I'll do the same for the second label, Control. I start running the application. With the changes made, the text now looks as follows. We can see a noticeable and much better change in the font applied to the application. Once this second section is finished, we move on to the collection of friends that you could have as part of the application. It shows who the person is, who is the friend, and how many images they have generated or have in their gallery of images generated by artificial intelligence. To implement this, we collapse the vertical stack layout and create a collection view for this list of friends. We indicate that this collection view will be in row number 2, that it will have an item source called Profiles, and its vertical options are equal to centered. To do this, we create a new folder called Models inside the project, and we did in a new class called Profile that contains the profile image, the friend's name, and the number of photos that they have generated. We also create another class called Generated Image, which we will use later. This class contains an image path, the keyword for the image, and the set of keywords for one of the images. First, we have the image, the main keyword, and the list of keywords that make up this image. Once we have these two classes, we proceed to the code behind of dashboard_view.xaml. As part of this class, we define the pair of properties that will be bound to the graphical interface. A pair of observable collections, the first having a generic profile and the second of generated image, each with a descriptive name for the bind from the XAML code. As part of the constructor, we invoke a method called loadData that we have not yet created and also indicate a binding context equal to this. Since in the same class we have these two properties that we want to bind. We will create this method called loadData, which is already prepared to initialize the list of profiles and the list of generated images with fictitious information. Since we have completed the code behind, we return to dashboard_view.xaml, where we need to modify the collection view as we have a horizontal list instead of a vertical one. To change this orientation, we use collectionView.itemsLayout and a linear items layout with an item spacing equal to 10 and an orientation equal to horizontal. Next, we define the data template or the item template to specify how the elements in this collection will be displayed, indicating collectionView.itemTemplate within data template. As part of this data template, we create a grid element, a set of columns that use 35% and 65% of the space, and define a height request equal to 60 and a width request equal to 160 for each element. Within the grid, we define the background of each of the spaces for the friend's information using a round rectangle that fills the entire space, all available rows, and a corner radius equal to 45 to give it that rounded look. Finally, we indicate fill equal to 1F252A and close the definition of the round rectangle. Once we have done this, we start running the application to see how this information that we are filling or this graphical interface definition is being displayed. Firstly, we have created the necessary space for the information of each of the application's friends, which looks quite interesting. Now, we're going to fill in the information for the profile image of the friends. To do this, after the round rectangle, we will use a border element with a row span equal to 2 and a margin equal to 5, 0, 0, 0. Additionally, we will indicate a height request equal to 50, horizontal options equal to start, and a stroke shape equal to round rectangle 80, 80, 80, 80. Within this border, we will use an image control with a height request equal to 50 units and a source equal to binding to a property called profile image. With this, we already have the images loaded for each of the friends. Now it's time to define the text for each of the sections. To do this, outside the border control, we will indicate that we want a vertical stack layout with a grid.column equal to 1, vertical options equal to center. And as part of this vertical stack layout, which will contain each of the friends' information data, we will use a label control with a margin equal to 10, 0, 0, 0. The font family will be equal to Nexa Heavy with a horizontal text alignment equal to start, a text bound to the property called name, a text color equal to white, and a vertical text alignment equal to center. With this, we can already see the name of each of the friends. Next, we're going to define a label control to display how many images each friend has generated. In this case, we will use a grid with one column, a margin of 10, 0, 0, 0, and a font family of Nexa Heavy again. The font size will be 12 and the text will be equal to the binding no photos, which is the property we want to bind to. In addition, we will add a string format to give a certain format to the displayed text, showing the number of images and adding the word pictures at the end. We will also indicate a text color of 869CBD and vertical options of start. With this, we can see how many images each friend has generated. The next step is to replicate the set of images that have the appearance of a collection or image gallery format. To do this, we will use a control that I found while browsing through the NuGet packages and that I found very interesting as it allows creating different effects to display that type of card. Therefore, I will proceed to manage the NuGet packages, and in the Browse section, I will look for a package called cardsview.maui by Andrei Misiukevich. I will select the projects and click on Install, which will start the installation process of this NuGet package. Once the package has been installed, I proceed to close this tab and define a namespace to be able to use it. I indicate XMLNS, cards equal to CLR namespace, pan card view. I use the pan card view assembly and define another namespace for the set of processors necessary to apply certain effects. I call this namespace proc equal to CLR namespace, pan card view, I am specifically interested in the namespace of the processors, which is in pan card view .processors. With this, I have the two namespaces necessary to create the graphical interface. I go to the MAUI program.cs file to add use cards view as part of the builder. I import the required namespace, which is pan card view, and with this, I am ready to start using this control. I go back to the dashboard view.xaml and compress the collection view that I defined earlier. I use the control called cards cover flow view and specify some properties, such as the location in row number 3, a margin of 25, 0, 25, 0, and an item source, which in my case is the collection I defined earlier, generated images. I also define some additional properties, such as position shift value, which allows me to place space between the different cards. I take advantage of this to add the processor through x:* arguments. I specify through proc, which was the namespace we defined earlier, cover flow processor. This is to create or add an opacity factor to give transparency to the cards in the back. I indicate that I want a 0.25 opacity for the cards and also want a scale factor, which is to make the cards smaller. In this case, I want each of the cards we see in the back to be 25% smaller. With the processor ready, I can now define the item template, how each of the cards will look inside this cover flow view. I define cards, cover flow view, .item template, and since I have this, I define a data template. Basically, it is a definition as if we were defining an item template of a collection view. In my case, I define a border element with a stroke shape equal to round rectangle, 25, 25, 25, 25, a stroke thickness equal to 0. Inside the border, I define a grid element with row definitions equal to 0.7 which is a 70% and a 30%. The grid element will contain the image and the label with the friend's name. As part of this grid, I define an image element with a grid.rowspan equal to 2, so that it uses all the available space, and an aspect equal to aspect fill. The source of information will be a binding to image path, which is the image generated by artificial intelligence. With the initial configuration of the list control, I start the application to see if everything works correctly. Done! With this, we can see the cards displayed as part of this control. It looks pretty good. We can scroll each of the cards and see the image as part of them, unfolding in a way that looks quite good. You can play with this processor's property if you want to achieve some different effect. We can also play with the value of position shift. In my case, what I did was add a value of -25 as part of the margin. If we leave this value as 0, the image appears in the center, but we can see an image to the left and an image to the right. So what I did was remove that margin that we specified initially as part of the application or layout. With this, we cast the image on the left not to be seen and the image on the right to be seen. The next step is to create some sort of grid to display information about the image. Those keywords that we have used can be used to generate a new image based on the information from the image generated by artificial intelligence. So, what we're going to do is create a grid element that I'm going to position in row number 1. Inside, I'm going to create a rectangle with a black fill. This with the purpose of having a section where we can add text. Similarly, I'm going to add an opacity equal to 0.5 and a stroke thickness equal to 0. I close this information or this tag, and we already have this grid element here where we can start placing the text information. After this rectangle, I'm going to create a vertical stack layout with a margin equal to 10, 0, 0, 0. Vertical options equal to center. Inside, I'm going to place a first label element with a font family equal to Nexa Heavy, a font size equal to 25, a text equal to a binding to main keyword, and also a text color equal to white. I close this first tag. We return to the application and here we have the main keyword of the image. Next, we're going to indicate that we want to create a second label control with a font family equal to Nexa Light since we want a slightly thinner font. Font size equal to 15. We bind to the text property of the list called keywords and a text color equal to white. If we return to the application, we can see that this time it is showing us the full name of the collection, and this is not really what we want. What we want is to show the set of words. We could solve this in various ways, such as creating some sort of converter or a property that would only show the list of words with commas. In our case, one of the easiest options is to install the .NET MAUI toolkit. This toolkit contains a converter for this and has more functionality that we could use for other things in case we want to further develop the application in the future. So I'm going to search as part of this NuGet package searcher for the MAUI toolkit. This first result, called community-toolkit.maui, is the one we're going to install as part of the application. We accept the terms and close this tab. We're going to go to mauiprogram.cs, and here's what I'm going to do. I'm going to indicate that I want to use the MAUI community toolkit. With this, we can already use the toolkit. We return to the dashboard view, and what we have to do is first create a reference, a namespace. We're going to do this XAML toolkit equals, and we have a specific namespace for the toolkit that's a bit different, which is this one, schemas.microsoft.com/.net/2022/MAUI/toolkit. With this reference, we can now create a new instance of the converter that we're interested in the resources of the content page. Let's define this section by indicating that we want a resource dictionary. We'll use toolkit : and the converter that we're interested in, which is this one called list to string converter. Basically, it converts a list into a string separated by a character. We'll give it an X key equal to list to string converter, and we can specify the separator between each of the elements, which in this case is going to be a comma. We save the changes, return to the keyword property, which is this one we see here, and we're going to indicate that we want to add a converter to static resource equal to list to string converter. I'm going to verify that everything is fine, and we're ready. We have the X key here. I'm going to copy the X key, and I'm going to start the application again to make sure everything is set up correctly. After a few seconds, we get the list of keywords related to the image we previously generated. These keywords are shown at the bottom, indicating that the converter works correctly. The last step is to create the green button that we see at the bottom of the screen. Although this button is shown like this in the emulator image, it can be placed in the lower right corner without any problem, and that's what we're going to do. Once we have declared the cover flow view control, I will define a border element and position it in row number 4 with a margin of 0,15, 0,0. The horizontal options attribute is set to end to place it at the end of the space. We'll use the stroke shape round rectangle 55, 0,0, 0 to round one of the corners. A width request of 250 units and content that includes a button with a background color equal to E8FF8E. Font family equal to Nexa Heavy. Font size equal to 16, a text that says create new image, and a text color equal to 101216. With this, we can see the button in the lower right corner of the application, which would allow us to go to the screen to generate new images with artificial intelligence. With this, we have completed the challenge of the graphical interface in .NET MAUI in which we have translated an image from Dribble design into XAML code for a .NET MAUI application. If you want us to continue developing this application and even get to the part of generating images with artificial intelligence using an API like DALL-E, leave it in the comments. I hope you enjoyed the video. I invite you to like the video, subscribe and activate the notification bell so you know when I release a new video, whether it's about .NET MAUI, .NET or development in general. See you in the next video.